Hello, in this video I'm going to solve question 3, problems set 3, lecture 4, lectures in elementary number theory. Let x, y, z, a, b, and c be integers such that x minus a, y minus b, and z minus c are all divisible by the natural number n. Show that x, y, z minus a, b, c is also divisible by n. Pause the video at this point and give it a try. Okay, so let us now solve the problem. Of course, the best way to solve this problem is using modular arithmetic, but because I am following my own lectures, we haven't reached to that part of modular arithmetic in my lectures in elementary number theory. So I do not want to use that, because if you use that, then if you're familiar with that, you can see that it is more or less obvious. But let us try to use the theorems that I have provided for you in the previous lectures. The theorem that I want to use here is the theorem that I presented in the previous lecture. So if I know that an integer divides b and simultaneously divides c, then the theorem tells us that this number divides any linear combination of b and c. So I can conclude that A divides, for example, m times b plus n times c, in which m and n are integers. So that is the theorem that I presented in the previous lecture, and this set of exercises is mainly based on that lecture. Okay, so if I want to prove this, this is somehow like a mathematical induction process. So this can be generalized to any number of these relations, as you will see. But let us just focus here. So if I have n dividing x minus a, and then the same n divides y minus b, according to this theorem, n will divide any linear combination of these numbers. But I have to choose that linear combination in a wise way that will help me to solve the problem. So for example, I can say that n divides, I want to have x, y here, so I will multiply this one by x, and then I multiply the other one by plus a. Yes. Okay, first of all, I want you to see that this is indeed possible based on this theorem. So a is being played by this n, b is x minus a is playing the role of b, y minus b is playing the role of c. For capital M and capital N, I have chosen y and a. Okay, so then if you open this up, what happens is that n divides, I multiply this in, so it becomes xy, I multiply this minus ya, then I multiply that, it becomes plus ay and minus ab. And then you see that this and that are cancelled. What I can conclude is that n divides xy minus ab. But I want to go one step further. But of course, you can immediately realize this is just a repetition of the same kind of argument. For example, if in your head you give it get the name of capital X, and then this one capital A, for example, then what you have n divides capital X minus capital A, and then you have an extra similar condition that n divides z minus c. So what I was able to show here is that if you have these the same n's, you can write the same n, multiply the first numbers, write xy, minus multiply the second numbers. So what you get based on the truth of these two is still valid. So I want to use the same argument, yes? So this implies as that if I multiply capital X by this first number, minus multiply capital A by this number, and also divides by that. So I prove this statement for the case that I have two divisibility relation. Then for the three divisibility relation, I will use the same argument for two divisibility relation. Then immediately you can see that this can be generalized to any number of finitely many number of these type of relations. Yes. So, and then if I ask you what is capital X times Z, because capital X was XY, so then you can see that n divides XYZ minus capital A is AB, so this becomes minus ABC, and we are done. I hope that you can see that immediately you can generalize this. So if you have x1 minus a1, n divides x1 minus a1, n divides x2 minus a2, and you know that n divides x sub m, for example, minus a sub m, then immediately using this kind of argument inductively, you can conclude that n divides the product of x1, x2 up to xm minus the product of a1, a2 up to am. As I told you that if you know modular arithmetic, this is more or less obvious. Yes, because when you say that n divides x minus a, this means that x is congruent to a module n. And this is more or less, we have a theorem that if we have two modular, if we have two congruency relations, then we can multiply them side by side, still it is valid. So that is more or less the same theorem expressed in the language of divisibility. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.